Okay, so now that we've taken a look at an overview of our arm deform rig, let's go ahead and start creating that rig in this video. So in this video, I actually want to get our lower arm clone in place and functioning correctly. So I'm going to jump over into Houdini. And to begin with, I'm going to duplicate our lower arm and create our lower arm clone from that. Now, when I do duplicate this, it's going to cause some errors in the network, and that's because our lower arm currently is referencing its inverse kinematics chop, and that's fine, we expect it to, because it is being driven by inverse kinematics. But when we copy and paste that node, then we're going to get the error where that new node is referencing the same inverse kinematics chop, but that inverse kinematics chop is not generating rotational information for that bone, so that will cause an error. We can clear that up first, and then we can continue creating our bone. So I'm going to Control-C, Control-V to duplicate our lower arm. Let's rename this to L_lower arm clone. Whilst we're here, I want to go ahead and delete out the kinematic solver reference on the lower arm clone. And now, as long as we cause the network to recook by just jigging our IK handle and undo that, you can see now our upper arm isn't erroring either. So we've got our lower arm clone. I do want to go ahead and delete out the references on the rotate parameters to our FK control, since we don't want this bone to be driven by FK. And we also need to delete out the stretchy IK parameters. So I'm going to come up to Edit Parameter Interface and shift select all of the stretchy IK parameters and the folder. The reason we're deleting these is because we're going to reference the lower arm bone's length itself rather than have to recalculate that stretchy IK a second time. So I'm going to delete out those parameters and accept. And then on the bone parameter tab, I'm going to reference for our bone length L_lower arm, the length parameter on that particular node. So now, if we were to take a look at what happens when we rotate either with FK or IK, you'll notice our lower arm and wrist are all moving fantastically, but the lower arm clone is not following along. So we're going to get this set up so that it uses inverse kinematics to follow that wrist position, to follow the end of the bone chain. And we already have that L_arm_end effector target position that follows along with our lower arm. We can use that as an IK handle for our lower arm clone, and that means we'll have a perfect clone of our lower arm. And from there we can then go about getting that twist effector set up on the lower arm clone. So I want to go ahead and create a new inverse kinematics chop. So I'm going to hunt down our kin chops network, and I will create a new inverse kinematics chop. Before I do, let's space out our leg kinematics from our arms. Since we're dealing with something up in the arm, we're going to have a number of kinematics chops by the end of our arm deform rig. So I'm going to create an inverse kin chop, and this is going to be our L_lower arm clone kinematics. It's going to be an inverse kinematics solver. The root bone is going to be our L_lower arm clone. So is our end bone. So I'm going to copy and paste that in, make sure that did take correctly. It did. And our end effector is going to be that L_arm_end effector target position. If we accept that, jump back up and find our lower arm clone and specify that newly created kinematics chop on our lower arm clone. So there's our lower arm clone kinematics. If we accept that, you'll see that now if we were to come in and rotate based on FK, our lower arm clone is coming along as well. So that is indeed working out fantastically for us. So we've got that lower arm clone in place. It's being driven by inverse kinematics. We can now hide out the lower arm itself, but we can now come in and create a twist effector for this lower arm clone, and that will allow us to roll the entire bone based on our wrist, because currently if we roll our wrist, as we'd expect, that bone isn't rolling. But if we have a twist effector that's parented underneath this, when we roll our wrist, that twist effector is going to roll around, and that will cause our bone to roll. So to create that twist effector, I'm going to branch off of our fetch wrist output, middle click, and branch off into a new null. And I'm going to rename this to L_lower arm clone twist effector. And I just want to translate this out in a negative X. So I'm going to translate out just in a negative X slightly. Something around about 1.6 seems to give some nice results. Really, the distance doesn't make a huge difference to the end result, but we will find that when we rotate our wrist other than just on Z. I mean, if we're only rotating on Z, the distance makes no difference whatsoever, but as soon as we put other interesting rotations on, then the distance does make a slight difference to the amount of twist that is applied, but it's very subtle. So I found around about a 1.6, negative 1.6 works really nicely. So I'm going to turn off, we'll actually leave the visibility on just for a second, just so we can see the effect it's having. I'll turn off the visibility in a second. And we can go into our Kinchops network, and I can specify as a twist effector that L underscore, it should be lower arm clone twist effector. There we go. We can see our bone has rotated round. That's fine. We haven't captured any geometry yet. We know that as soon as we do capture geometry, then we obviously want to make sure capture regions and the likes are set up so that initial rotation hasn't caused any issues. But as long as we say, oh, hey, this is our base position, that's going to be fine. So all is good there, especially as we're not actually going to be capturing geometry with this bone itself. If you were to set up the character to be captured by the bone setup, you'd want to set them up to be captured by the ulnar and radius bones that we're going to be setting up in the next video, although we aren't going to be showing capturing geometry in this DVD or the next DVD. That's something that's beyond the scope of this focused DVD product. But now that we have that twist effector in place, as we rotate our wrist control, we're rotating that arm bone. And the reason I wanted to do that using a twist effector as opposed to simply having our ulnar and radius parented in and having their end effectors parented in is if we rotate our wrist back like so, or forwards like so, if the end effectors of our ulnar and radius were parented in, they'd be getting affected. And you'll see later on that what we're actually going to do is parent them in to this bone, so that a rotation like this isn't going to cause those end effectors to move further away or closer to the elbow. However, we are getting the result that we wanted when we rotate around Z, so that's exactly why I've put in a twist control, a twist effector for a clone of our lower arm, as opposed to having something where we have just an ulnar and radius bone and the end effectors are parented into that control. If the end effectors were parented into the control, they'd be affected by rotations on Y. Their end effectors would get further away and closer. That would cause all kinds of differences. We only really want them to be affected by that rotation on Z. So with that, we can turn off the visibility of that newly created null and the selectability, and that is going to conclude this video where we're setting up the lower arm clone. In the next video we'll go ahead and get our ulnar and radius bones created. Thanks a lot everyone.